Hello, everyone. I hope you enjoyed the keynote. And now it's time for our next session. It is my pleasure to introduce Yuri Winch Antman, an aerospace engineer and data scientist turned entrepreneur. He spun off a deep tech research project into a startup in Germany using computer vision to solve costly challenges in the manufacturing industry. Yuri has contributed to projects with NASA, Innovative Advanced Concepts, and MIT Genesis, worked with Artifact Data Consulting and Fraunhofer IPT, and advocates as a software innovator and the One API Student Ambassador Program. And so this session, we're going to do a hands-on. And before that, I want people to understand there are only 50 seats open for this workshop. So we want you to still, even if you can't get a coupon, we still want you to participate, ask questions, and so on. Yuri will, in the course of this workshop, will walk you through how to create an account on the Intel AI Tiber Cloud, and so on. So with that said, please join me in welcoming Yuri and his workshop titled Fundamentals of LLM Fine-Tuning Techniques. Over to you, Yuri.
Awesome. Hi, Shri. Thanks for the introduction. Hello, everyone. It's I gotta say it's a big honor to kind of kick things off here in this awesome event with such cool topics on the agenda. I took a look, and myself, I've registered for a bunch of them. So yeah, I'm pretty excited. Such a cool event, and I also got to thank Sri and Susan for putting up this cool idea of event, and I'm sure it was a great deal of effort to organize it all. So I also want to encourage you guys to demonstrate some love for them here in the chat. And yeah, with all things said, let's get down to business. Let's approach our topic here of this workshop that we are gonna be doing. So as you guys already know, the topic that we are gonna discuss here is the fundamentals of LLM fine-tuning techniques. So we're gonna go through some of the most popular techniques out there, and yeah, let me also show the agenda here that we are gonna address. So yeah, first we're gonna briefly just go over the basics of LLMs, just from the start of the LLMs, what was the big innovation that could generate this big breakthrough for us. And then we're gonna look through the this next section, which is making use of the open source LLMs. We're gonna see some of the biggest models out there, and next we're gonna see some of the alignment techniques, which is the core of our talk here. And finally, we're gonna do some hands-on and some of the cool stuff, in my opinion. So yeah, as we are gonna spend a couple of hours here together, I thought it was polite to kind of introduce me a little bit more than Sri did. So yeah, as he said, I'm an aerospace engineer. I'm also a data scientist. I love FPV drones. I did some projects with NASA, NIAC, Innovative Advanced Concepts, with a lab from MIT. Also worked with data consulting and in a research institute in Germany, and then I opened a startup, and yeah, also an ambassador for Intel, and yeah, we're gonna. I think this is enough introduction for now. So yeah, first thing that I wanted to ask you guys is three prerequisites that we have for this workshop. So the first one is to have an Intel Tiber account. I have all the links here, so you can just write them down and in a browser. And I'm gonna leave some time for you guys to copy all the addresses. So the first one is the Intel Tiber account. Then you're gonna have a Hugging Face account if you don't, and also a weights and biases account for us to keep track of the trainings that we are gonna do. So maybe let me know in the chat if I can skip the slide, or if I should give more time to copy the addresses. Yeah, I can surely put the links here. Just let me try to copy. Just 1 second. Yep, there we go. If it doesn't work, the links, I guess Susan or Shri can help you out with this. But yeah, let's skip ahead to the next thing, that the next slide that we are going to cover. So here, actually, I'm going to go through with you guys on the Intel Tiber. So while you guys are creating the accounts, if you don't have yet, I'm going to just go through some parts here, because I think it's really interesting to see some of the stuff here. Maybe you guys don't know yet. But yeah, here in the Intel Tiber, we have a catalog of all the hardware available that you can use on demand. So we have a couple of CPUs, GPUs, and also we have some cool features here for software that you could use some streamlined deployment for your AI. So using Seeker Flow and Prediction Guard, those are pretty cool LLMs apps that you could use to deploy your AI. And also this Intel Getty is really cool for computer vision as well. So you might want to check this out later. Also in the compute instances, you have a couple of, let's see, CPUs as well that you can deploy in a VM. Also some GPUs in the Max series. The CPUs are the Xeon processors. And one cool thing that I just actually saw here in the catalog is in this preview catalog section, we have here available some of the newest available XPUs or processing units from Intel. So we have here the Gaudi 2, Gaudi 3, which is incredible for performance. We also have the new Intel Core Ultra processors. I have one here with me. It's an amazing APU. Like you can do a lot of stuff with this little device. And yeah, one cool thing that I saw is they already have here listed the Xeon, the sixth generation, which just launched, was released 2 days ago. So it's awesome to already see it here. So yeah, I think I already gave time enough for you guys to create some of the accounts here in Intel Tiber, also Hugging Face and Weights and Biases. So yeah, let's cover some of the housekeeping rules here, how we are gonna operate in this workshop. So during the workshop, we're gonna have some like pretty technical stuff, pretty broad approach on the topic, and later we're gonna do some more like practical and hands-on. So we're gonna go really on the macro vision and go to the micro vision and put it onto the test what we have seen and maybe learned. So I want you guys to let me know if you're following or if you're confused or maybe falling behind on the concepts and on the steps. And also one thing that is important to make sure here is to expect some bugs, because I've tried the code and sometimes it's a little tricky. It's kind of complex what we are gonna deal with. So also expect some troubleshooting and maybe a little frustration. I have some plan Bs for possible errors. So let's hope it all goes smooth. Yeah, well, so let's get back to our Intel Tiber. We're gonna be going back and forth between the slides and also the platform, the cloud platform. So yeah, one thing that I want you guys to do here in the Intel Tiber is to open your user drop down here and go to this cloud credits, and you're gonna access this screen here. And I'm gonna provide you guys with a coupon so you guys can redeem it. So yeah, I just put it in the chat. And yeah, what this coupon is gonna give you $1, which is enough, more than enough for you guys to use all the learning notebooks here in this drop down that you're gonna see here in this sidebar. So yeah, once you redeem this $1, you're gonna be able to run for a couple of months with this using the notebooks here from Intel Tiber. And yeah, let me know if you are following, if you could redeem it. I'm gonna take a look here in the chat. So Albert, you said you got something went wrong error message when I tried to sign up for Intel Tiber. Am I missing something here? Can you be more specific? Like, what have you seen and what page have you tried to sign up? So yeah, I'm gonna assume you guys have already redeemed the coupon. If not, Tree can help you guys with this. So what you guys are gonna do is go to this notebook section, and you're gonna scroll down to this let me get the name. You're gonna scroll down to the Gemma model fine tuning. Yeah, there we go. So you're gonna scroll down to this Gemma model fine tuning using SFT and LoRA, and you're gonna click launch the Jupyter notebook. And once you click it, you're gonna be redirected to this Jupyter notebook page. Let me know if it works on your end. So in this part, we're gonna have to do some refreshing of the development environment, because we're gonna make sure that all the cache or the kernels and the terminals are like fresh for us to start working. So the first thing we're gonna do is open a new tab here in the Jupyter page, and we're gonna select the terminal, and we're gonna just write cd tilde. So we're gonna move back to the root folder, and then we're gonna write rm -rf dot cache slash dot ipython dot local. And yeah, what this is going to do, it's going to basically delete all the previous setup that you guys started, like in the kernels, or maybe some things that were already there. And once we have this fresh, we can just click on log out, and this is going to make sure all our environment is going to be pretty much new. So yeah, again, let me know if it you guys are following or falling behind, if I should help with something. So Marco, once you open a new tab, you select the terminal. Yeah, correct. Oh, sorry, I'm gonna paste all the comments here in the chat as well, so you guys can just copy and paste there. And yeah, one thing that is important to mention, also let me know if you have any return from this second command. So if you have any output from this, you gotta also clean more of the directories. But yeah, if some of you have this problem, let me know. If not, we can just keep moving. So Rogers, basically you just gotta create a account for Intel Tiber, also for Hugging Face and Weights and Biases. All the links are in the chat, up in the chat, and basically you're just gonna redeem the coupon code that I also pasted there, and you're gonna open the notebook that I'm also gonna paste the name here. All right. So yeah, during this time, I think you guys are gonna be doing some of this stuff. I'm gonna cover some of the theory here for us to be on the same page. So I think one cool thing to like assess the audience is I wanted to ask you guys if you have already done have already coded any LLM or any neural network in general. or if you are a developer, but like a software developer. So I think Shri has opened a poll here, so you can start voting, and let me know if you have any experience with LLM, or if you are like on the business side, if you are just curious to learn more on the topic, so that I know how deep to go on the topic, and how deep to go also on the code section. But yeah, getting things started. The first thing that we gotta mention here when we are talking about LLMs is probably the holy grail of the beginning of it all, and it is this new cool architecture that they invented. It's the transformer architecture. I think, if I'm not mistaken, it was developed by Google DeepMind, and they released an article called "Attention is All You Need." It's pretty famous. I guess many of you guys have heard of it, or maybe have read it. And in this article, they describe this really cool new architecture that has this new feature that kind of solves a lot of the problems that were not being solved by the previous architectures, like the convolutional neural networks, the also the RNNs. And this feature is basically the attention layer. And this attention layer is pretty cool because it lets the model to handle a long range of dependencies in parallel, and it lets you focus on the primary features that you get from the input. So yeah, basically with this, we enabled a lot of things with the LLMs. So if probably all of us know, but it enabled the text classification, also a lot of question answering, translation, summarization, text generation, and a lot of those modalities are being approached by those big large language models that I've listed here underneath. And what is cool about those is that they are a lot of them are open source, and we can freely make use of them. We can load them in our computer, in our servers. We can fine tune, we can adapt them for our specific needs. So what we are going to go through here is like how to make the best use of those giant language models that we have available in the market. So here I put a cool video that I just got today from the chatbot arena. So it's a comparison between the top 9 companies, comparing the Elo scores. So it started from August 2024 until February this year. And we see here a lot of the peaks of those models, the recent peak from DeepSeek, also the Grok 3. And the cool thing here is you see like a lot of those companies are like putting a lot of work day by day and improving those models, and we can just take use of this and retrieve those models and like adapt and do this fine tuning that we are going to run through. And you know, like we don't have the headache to create a big model. We just can use one and adapt for your specific user need. So I also put here a table of comparison of those Elo scores, because it really varies. Some models are really good for a couple of specific things, So it was just to make sure that it's not like misleading this comparison here, because this is the overall LO score comparison. Yeah. So just to finish this first basic idea of the LLMs, what does the LLMs comes with? So basically, the game here is about data. So training those LLMs are basically large clusters of accelerators using massive data sets, and those result in emergent properties that we see here as the reasoning, problem solving, and also a lot of creativity features from the LLMs. And those LLMs use massive data sets from the available internet data, and those models, they come up with the foundational models that we are gonna be using here in our code. So yeah, going back to our hands-on, what I want you guys to do is to, if you already ran this code here, executed in your terminal, I want you guys to, let's go back to this page. You can close this browser, this tab, and let's go back to Gemma. You can launch that again. And this way, we make sure that we're going to be using a fresh dev environment. Just let me log in. It's probably going to ask for a code verification. So just give me a couple of seconds for this. Is there any questions in the chat that I could address?
Yeah, Yuri. A lot of folks are still trying to get to how to get to the notebook. So basically, I think what I've said is going to learning, click on notebooks, and then type in Gemma and search, and then hit the launch button.
Correct. Yeah. Yeah. You can just do a like Control F and you type Gemma, and you're gonna reach this this box here, and you just type just click launch, and you're gonna be redirected to this page here. Did it work?
Open a notebook without a coupon. Somebody has.
Okay. if it works.
Yeah, that's
no problem.
probably because it's the free tier of the.
Yeah, maybe he already has some credit. I don't know, because yeah, some of the notebooks require like you having at least an amount of credit on your account. Okay, so to redeem the coupon, Babak, you just click here on your user button here, and you're gonna see this cloud credits. And once you click, you're gonna get this page, and you just click on this redeem coupon, and I'm gonna paste the coupon again here, so I'll make it easier for you. All right. So yeah, awesome. So So yeah, once you're here in this page, you're gonna get this notebook, the Gemma XPU fine tuning notebook, and we're gonna briefly run through the first setup here. If you guys have any trouble here or executing anything, just redo the steps that I told you, like open a terminal. Also, make sure to shut down all the terminals, then open a new terminal. Then you can run the code that I sent, the command, and you log out and open again this page. It's probably gonna work after you do this. So yeah, the first thing, we're gonna install a couple of libraries here. So yeah, it's gonna take some time. So basically what we are installing is the datasets library for us to access the dataset that we're gonna use to fine tune our model. We are also installing the weights and biases dataset. We're going to install PEFT and TRL libraries as well, because those are the things that we are going to use for the fine tuning. Yeah. So now we're going to just set the environment to optimize for the Intel GPU. So here, what I recommend you guys to do is to comment out this line here for the LD preload. I'm not sure if it is enabled, but just to avoid some possible mistakes, I recommend you guys to comment out this line. So I'm also gonna paste in the chat so you guys know what I'm talking about. So yeah, basically what this section of code is doing is setting the environment variables for us to use the Intel GPU in the most proper way. Yeah, so awesome. We have it set. We have a list of 96 cores open for the threads, and yeah, what we are gonna run now. Let me check. Yeah, those are just some functions that we're gonna later use to just like get some memory usage, print the usage, and so on. Just some operational stuff. So yeah, this sometimes we get some errors here, and it's okay if it doesn't work. For me, it's working. So. Cool. Yeah. So awesome. So the next thing, once we get all the environment set with those variables, now we get to the point that we are going to start the fine tuning. And before I do this, before I reach some deep level on the technical stuff here in the code, I want to move back to the slides, and I want to let you guys also take a look in this notebook, check the code, read stuff out, so you get more familiar with the stuff here. Because honestly, I don't have time to cover it all, so I'm gonna move back to the slides, and we're gonna touch some of the theory of making use of the open source LLMs. So yeah, basically the idea here that we're going to use as the architecture is we are going to provide a query as a user. We're going to send this through the front end in the client side. And this is going to reach for the server side, and the server side is going to make use of this foundational model that we talked about. And all the inference backend logic is going to be run in Python. And yeah, this is the full architecture. It's pretty simple. It's all of the LLMs online that you use this architecture. But the thing is, the question I raise is: are the emergent properties enough? Like, the question is, in this real world applications, can we rely on all of those foundational models as the sole ground truth for us to use in your business or in any type of application that you try to implement? And the answer is probably not. So we cannot rely for. We listed here three reasons, and the first is a lot of hallucinations. So in very specific or niched applications, some of the LLMs, mostly the smaller ones, they tend to hallucinate a lot. Tend to make stuff up. They tend to create false truths. And this is something that we want to avoid with this alignment seek that we're gonna talk about later. And other thing is we are also relying on outdated facts, or not even outdated, but sometimes just misleading facts or simply wrong facts that the LLM was used to train. So we don't want to base our business on this data that they use. And sometimes you get also DOS, the denial service. So we cannot always rely on the service of those companies. And so,
Yuri,
yeah.
we have a question in the chat. Somebody wanted you to explain what is an emergent properties before you move forward. Could you explain some what that meant?
So, yeah, I think here this slide explained the idea of the emergent properties. So the concept of the emergent properties is basically the core value, like the core value that we get from the LLMs itself. So it's the reasoning capabilities, it's the problem solving capability, and also the creativity capabilities, and so on. But basically those three cores are what define those emergent properties from the LLMs. Does this explain, or still a little vague? Yeah. So yeah, moving on with this alignment seek. Yeah. All right. Awesome. Yeah. So it's basically the core. The properties is the capability of reasoning based on the ground truth that you want to set for your LLM. So let's say you have a business and you have all your data, all the knowledge base that you want to set. Some of the emergent properties are like the reasoning that you can do based on the stuff that you came up with in this knowledge base that you created. So yeah, the properties are basically just kind of emulating a human brain with an LLM. So yeah, moving on to this alignment seek. The techniques that not the techniques, but the thing that we want to get here is basically we're going to have a question about A, and we expect an answer or an advice about this topic A. And what you don't want to have is an LLM hallucinating or answering B to a question about A. So to provide this assurance, to do this alignment seek, we have three possibilities, three approaches for for this solution. And those few ways for us to do this are, the first one is the fine tuning, which is the one that we are gonna code itself. The second one is the grounding. So we're gonna I'm gonna explain later. And the third one is the guard railing. So first one, let's explain the base theory on this this technique. So the fine tuning is basically you get this model, you get this big large language model with all the weights, all the biases, all the constraints with the pre-trained conditions from this model. And what we're gonna do is we're gonna load all this model. We're gonna not always train the full model architecture. Sometimes we're gonna reduce it to make the training easier. But basically what we aim to do with the fine tuning is changing the weights. So this is the final goal with the fine tuning, is changing the values that we archive, that we save on those weights. And for this, we need to have a lot of databases to train again this model. And the core idea of the fine tuning is changing the model. So we're going to have a totally new model. And the next one that we mentioned is the grounding. So in this specific technique, we don't change the model. Also, in the last one, the only technique that changes the model is the fine tuning. And using this grounding, which I'm sure you guys have heard of it, maybe from a different name, because we have a specific technique called RAG here, the retrieval augmented generation. And the RAG is also a type of grounding. And what we do with the RAG is basically we get this user prompt, we get the input from the user, and we run an analysis on this input. We get some tokenizers to find the specific. We get some embeddings to get the tokens from the specific input that the user is providing, and using those, we run through all our base knowledge, our private specific knowledge, and we do this retrieval of the context that we are going to generate. So we are kind of providing some context, some extra content inside this prompt that the user is providing to the LLM. So before we provide to the LLM, we kind of like embed some context from our specific private database. And with this, we get a more enriched version of the output with all of the specific data that we provided in the pipeline. So this is the grounding. And the last one we're going to see is the guard railing. And this one is pretty much like checking for like the first and last step. So it's a kind of guard railing, as the name says, especially because it's especially trying to look for some policy enforcement, for some alignment of some like governance, trying to set the limit of some answers that the LLM might provide. So we're gonna basically run a filter on the answer and also on the input, if you might, and we're gonna try to see for some breaches on our governance policies. And yeah, this covers all the idea of the alignment SIG. We have here a chart that we see very graspable ideas of applications for each one of those techniques. And the first one here, we see an application for a clothing retail customer chatbot. And in this first example, the idea is to use a RAG and also with a pre-trained LLM. And the idea is, the reason is that we don't need any model behavior adaptation. We don't need to do any pre-training. We don't need to do any post-training. We don't need to also get like a vast amount of external knowledge. We do need to get an external knowledge because we're gonna run this chatbot. But yeah, the only thing we need is the knowledge that we are going to provide for this chatbot, and we don't need to rerun any of the trainings. So for this chatbot, that's the case. But for a medical advice chatbot, it would probably be more suited to run a RAG with a fine tuning. So we get a totally new model, more suited for a medical application. So it gets more data within the model. It's more like used to the questions, to the embeddings. And we also provide a RAG. We also provide like vast amounts of external knowledge for the LLM. And we also have some other examples like building a general API inference service. This would be just like a pre-trained off the shelf, like a wrapped version of any LLM available, and also a task specific model adaptation, like a sentiment analysis. This would probably work better, not with any RAG. We don't need any database for this, but a fine tuning might work better for the model to analyze or identify those sentiments. All right, awesome. With this, we conclude our theory on the alignment SIG. So all the techniques on fine-tuning or seeking alignment in general, we have seen. And now I think it's cool that we move back to the code and we finally do some coding itself. And before that, do we have any more questions here?
We have a few. I think Rakashan, one with type error, and then Marco had a file save error. And it could be possibly that we hit the limit on, there's 55 people in the session. So it could be a possibility that only 50, because there's a limit of 50, it could be possible that we're running over that limit. But I've asked our cloud folks for clarification. So
yeah, it could be. Maybe some of the folks are already ran through the next steps on the code, and maybe this is the reason, because we do need to do some adjustments on the code for it to work properly. So maybe that's that. Maybe not. So let's move on with the code from the position we stopped, so we can maybe see if we can solve your problem. Yeah. So in this section of on the step 3, we're gonna configure the LoRA settings. And LoRA is basically a framework that people use to run the fine tuning on LLMs. And the definition for this acronym is the definition for the acronym is the low rank adaptation. And what we're going to do in this LoRA configuration is, I think you guys have different numbers here. What I'm going to ask you guys to do is to set the numbers for the rank, the R argument, you're going to set to 8, and the alpha, you're going to set to 32, because it was working better, easier for a short time workshop. And also, you're going to change the target modules for just those 3 ones that I have here. I'm going to paste this in the chat so you guys can just copy. Yeah. Let me know if you guys are following. So to give a brief explanation of those arguments here, the reason for each one of them, the first one is called the rank. So in this procedure of using LoRA, which is the low rank adaptation, what we do is we use this rank, which is gonna kind of compress the model into a smaller and more efficient version of the LLM. And this rank argument is what sets the level of compression that we are going to use. So I found out that 8 was a good measure here, and it works good with our short time, because it's also gonna compress a lot the model. And the higher the rank, it means like more modules. So the lower the like 8 is a number that is compressing a lot the model. And alpha here is basically defining like how much does our new weights is gonna influence the model compared to the previous original weights. So we're gonna have new weights for this model, and we want to also use an argument to set like how much are we gonna allow this new weight to influence the previous model that we had. So we're gonna put a pretty decent number. We could go higher, but yeah, it's something that we need to try and see how it works better. And yeah, any other questions? So where can we get the guide to set up those parameters? Can you maybe explain better? Can you linger on this this question? I don't know if I got it. Is it possible to share the file of the presentation? Yeah, I could share the file with Sri, and he could share with you guys in some way. We can figure out at the end of the talk. So the target modules that we are reducing here are basically what defines, like, I'm not sure about those, because it's pretty fluid. It depends on the architecture that the model is using. So here we're using Gemma, as we said. The model that we are gonna fine tune is Gemma 2, which is a model from Google, and this model uses those modules names, probably like question, value, key, something like this to reduce the scope of the modules that we are gonna retrieve from the model to run the fine tuning. So awesome. I think I ran this. Let me run again. And the next thing we're going to do, we're going to move on to this next block of code, and we're going to run it. And I'm going to ask you guys to open your Hugging Face account. So I'm going to open mine here. Let me share my screen here with the Hugging Face account. So yeah, let's go back. I see another question. So why are we using the rank value 8, not rank value 4 or LoRA alpha 32 and not 16? So that's a good question. Mostly people that are running this fine-tuning process, they just play with the numbers. They just so you get basically a lot of different results from each of the trainings that you do or the fine-tunings that you do with different numbers. And the thing is, this is just a trial. I'm just giving like a propose for you guys to use. It's a good number. I also looked up on some threads online from some people. They use basically a ratio of something close to this 8 to 32. So there's some golden rule here that people normally use, and it works. But the best thing is you run a lot of fine tunings, and you just also run the assessment of those models to get the score, and then you see what works better for you. But the reason for 8 and not 4 is like we don't want to comprise the model so much that it's not like workable for us. It's not useful for us. So a probably rank of level 4 would reduce too much the model that it wouldn't be really useful for us. I don't know if it clarifies your question, Eric. But yeah, moving on to this block for the Hugging Face. Again, you're gonna run this code and you're gonna get this output, and it's gonna expect you to paste a token here. And this token we are gonna get from our Hugging Face account. So when you log into your Hugging Face page, you're gonna click this button for your profile, and you're gonna scroll down to this access tokens. All right, you're gonna click, and it's gonna open this page. Maybe you have some tokens, maybe not. What you're gonna do is create a new token, and you're gonna make sure to give this right permission or policy, and make sure it's not just read or not fine-grained, because you're gonna need to set all the policies if you select the fine-grained. So you're gonna make sure to select the right policy, and you're gonna place whatever token name that you have in mind, maybe Intel Workshop LLM or something. I already have one token. So once you create, you're gonna get something like this. So let me refresh mine. And you're gonna get some pop-up like this, and you're gonna copy your token. So make sure to follow all those steps. Make sure to select the right permission. I'm gonna paste this in the chat so none of you lose this information. So you're gonna make sure to select the right permission, and you're gonna paste the token here, and then you click to log in, And once we are logged in, we are good to run the next code, which is gonna basically, what this code is doing is, first we're defining the model ID that we're gonna use. And as I said, we're gonna use a model from Google. It's the Gemma 2B for 2 billion parameters. And you cannot log in because you cannot save the notebook. Maybe this is something due to the credits that it's restricted. Maybe try again. Maybe reload the notebook. I don't know. I can get back to you in a minute. So yeah, we are here defining the model ID that we're going to use, and this model ID comes from the Hugging Face. So if you open your Hugging Face and you paste this model ID that we have here, let me get it. So we're going to paste, and we're going to open the page for this model in Hugging Face. Basically, what we are doing is we are selecting this model, and here the tokenizer is we are fetching the tokenizer for this model. So yeah, here in this line we are retrieving the model itself. So it's getting the pre-trained weights from this model, and it's saving in our server memory. Yep.
Yuri, some people are saying that they're not able to access the model, that they're not on the authorized list.
Good. Yeah. Awesome. This is one of the things that I was expecting to happen, and it's good because it's a controlled scenario problem. So the thing that you gotta make sure to have is an authorization from this Google Gemma 2B for you to retrieve the model and use it. So once you go to this Hugging Face page with the of this model, you're gonna scroll down, and probably around somewhere here you're gonna see some button for you to like request an authorization, and it's probably gonna ask for your email verification or something. I don't know about mine because mine is already authorized, but yeah, you just gotta make sure that you are authorized to use this model. And yeah, you can see here, if you have this message here, the gated model. So once they set this gate, you cannot use before you're granted the access to it. So yeah, just ask for the access and you're good to go. And then you can run this section of code. So we're gonna go ahead and load our model. So as I have the access granted, it is loading all of the models. And one thing it does, so this model is not that big, and usually Hugging Face sends the weights of the model in how do we say this, in chunks of data. So it's sending the first chunk of data here, so it's the model 00001 of 2, and it's gonna first load the first chunk, and then it's gonna load the second. So it's more like safer for you to store your data and not like get lost in like a big set of data that is being transmitted for you. So what we gotta do now is wait for it to load. Maybe we can check the following code here because it's gonna take a while. So the following code is basically what we are gonna do is we're gonna test the model. So so before we start the fine tuning, we gotta see how good our model is. And spoiler alert, this model is not that good. And the reason we not me, but the engineers from Intel that choose this model to do this workshop, is that it's a good model for us to run this simple example of a fine tuning, because it's lightweight, is super easy to load on a server. It's not overloading our memory. So we're gonna once we run, we're gonna see the model is not that good operating and answering those questions, but what we want to see is at least some difference between the answers of the first test and the last test after the fine tuning. All right, so yeah, now we are set. The kernel is idle because we have fetched all the data from the model, and now we can just run this test. So we have the model here in our server. It's operating locally in this Gaudi. I think it's a Gaudi server, and yeah, it has already answered all our questions. So we separated 5 questions here, and you see the questions does not always make sense. They don't always make sense with the subject that we proposed. Like I said, what we don't want to have is a model hallucinating, or we are asking about A and it's answering about B. And what we are going to make sure now is to try to fine tune it to make more sense. And now we are going to prepare the data set that we're going to use for this fine tuning. So the data set selected here is the data set from Databricks. It's the Dolly 15K, because it has 15,000 questions and answers. Questions and answers. And what we're gonna do here is select the types of questions and answers that we want to use for this fine tuning. So it's kind of doing a filter here, like selecting the categories to keep. So we're gonna go ahead and run this. It's gonna retrieve the model from Hugging Face as well. So let's show this. I think this is one cool thing to see. We're gonna go back to Hugging Face again, and we're gonna paste in the search bar the Databricks Dolly 15K, and you can see here all the data, all the info about this data set that you can use. And we have plenty of other data sets that you could use. Some data sets are more specifically they are like better for different applications. So this is a general data set that we could use for like any type of fine-tuning scenario. So yeah, it's already in our memory, in our server. So what we're gonna do now is just map the split the data set and map it to the train and test parts of this data set. And the next code is the fine tuning itself. So this section of code here, I want to run line by line with you, because we have a lot of adjustments here to do, to make here. Maybe you guys can try to run it already, and you're gonna see we're gonna get some errors. And from my experience, the errors, they come from new versions of the TRL library. And in this new library, we don't have this attribute set, the arguments for packing, for max sequence of length, and for the data set text field. So the first adjustment that I did in this code was to comment out all of those lines. So make sure I'm gonna paste here in the chat again the lines that you might want to comment out. And the next thing that you want to do is we're going to set a name for our weights and biases project. And with this name, you're going to later have an access to a page for you to follow along the training of this fine tuning of this model. So you just go ahead and put whatever name you have in mind. I just put here my new AGI because I think it sounds cool. And those next two lines, you can just leave it as it is, because it's just setting some variables for the weights and biases again, and for the IPEX, which is the library from Intel. And the next thing, you want to make sure to put your username from Hugging Face here. So you're gonna set whatever name it is, you're gonna change it. I think it's from Onho, the name, and you're gonna change for your username from Hugging Face. So you're gonna just copy this username and paste it here. And then you might just want to use the same name that you use it here for the model that you are creating. So this model, we are gonna still use Gemma to be, we could use a better model. It would provide better answers, but it's just easier for us to use this small model for now, because it's gonna make the training faster for us. So the next thing that we want to change here is the batch size. I think it's probably set to if 2 or 4, the batch size here. So I wanted to change it to the number 1. So set the batch size to 1, set the gradient accumulation steps to 4, and set the number of epochs that we're gonna run on this fine tuning to 1 as well. So we're gonna just run 1 epoch. If you guys are not familiar with the epochs concept, the epochs is basically the number of steps or the number of reruns that we are gonna do on this fine tuning or the training process. So I'm also gonna paste this in the chat, so we have it saved in one place. And the next thing that I want you guys to change is make sure also to add this last line in the training arguments. So you're gonna have a bunch of arguments here that they are gonna set the parameters and the conditions for the training that we're gonna run. So for example, we have the warm-up ratio, it's set to 0.05. We have the learning rate. This is a big argument that it's super important for you to might do some adjustments or trials, changing the learning rate. What else we have? We have some save steps. So it's the amount of steps between each other that we are gonna ignore. So we are gonna save 1 between 500 steps in our memory, and we're gonna log 1 between 100 of those steps. So we're gonna see every 100 steps here on the output of this code. Yeah, basically what I want you guys to do is just copy this last line in the end of this training arguments, and make sure to also place a comma here, because it's not going to work if you just paste the last line without the comma after the group by length. So the next thing I want you guys to do is to paste this section of code here. So we are gonna kind of reduce the amount of data that we are gonna be saving from this data set, because without those arguments here, it's kind of overloading the server. And in my experience, we're not gonna have enough space to run everything and all of us at once if we do not reduce the amount of data that we keep. So we're gonna do some pre-process to like run some truncation, and basically what is being going on here, we're gonna make sure it works with this function that we are defining. All right, so I think we are set with this last change. I'm gonna send the whole code block, because if you didn't follow any of the steps, you might just wanna, oh, I cannot paste more than 500 characters, so yeah, let me paste the first section. I'm gonna paste in different chunks. Yeah, it's it's limiting a lot my messages, so just make sure you guys did all the modifications I mentioned it. And if not, if you didn't follow all of them, you can ask in the chat, and I'm happy to provide some help. All right, so we're gonna go ahead and run this code. So yeah, we're gonna see it's mapping the training and the validation splits. And here, not in my case, but probably in yours, you're gonna have a link for you to set your API access for weights and biases. So you're gonna probably see something like WNB.ai/API, something like this. And then you just copy this link, and then you open the link, and it's gonna right away provide you with a token that you're gonna paste here, and then you just run. And once you have it running, you can also open this. Let me show you guys. So yeah, I'm not logged in. Let me see if I can log in here. Yeah, so here I'm already logged in. And here we can see all the steps. Like we can follow along the training. We can see. Let me see if it's. Yeah, it's up to date. Yeah, it's training the my new AGI. Probably this one, because we have only one epoch, and it saved just one of the logs that we said, like once every 100 logs. Once every 100 steps. So yeah, this is the page that we from weights and biases that we can follow the training steps that we are making with this fine-tuning of the model. So it's pretty cool, because we can see some of the evaluations, some of the loss features here on a graph. It's not showing at the moment because I'm not logging too much data, and I'm also doing one epoch here. So if we do more than one epoch, you could see like a smooth graph. Yeah, there we go. We can see just the first maybe 2 logs, because it's going from 100 to 200. Yeah, so we have 2 logs here, and it's going straight away to our weights and biases. And once it smooths out the line, we can see we can have a good analysis of the training process, like what we need to change. For example, what should we change regarding the rank from LoRA? What should we change regarding alpha, regarding learning rates? From those analysis here, we can have more like a grasp on the attributes that we could adapt. Yeah, this is a full page for you guys to access. But we also have 8 minutes available for until we finish with the training, the fine tuning. So if you guys have any question, any complaint, any idea, any comments, I'm all ears. Maybe if we wants to raise another poll for you guys to for us to see who's following following the steps. We could do that as well. Let me know how long you guys still have for the training. Yeah, I see Himanshu said that my training is progressing way faster, and maybe that's due to some of the arguments that I said, and maybe you said some arguments different than mine. So I said here, let me show you what the batch size of 1, which reduce the amount of data that is coming from in one batch. I also, this is not gonna change anything because the number of epochs, I mean, it is, but probably not affecting you. So yeah, I set the number of epochs to 1, and I also set this function that runs this that sets the data fit set future text and the max length to 512. Maybe this is what is reducing my time of training as well. And most importantly, also the LoRA settings also affect a lot on this the time that you spend on training. So the attributes that you set here for rank and for alpha probably define the speed that you're gonna have for your training. Let's go back to training page so we can follow along. Yeah, so we are in the step 600. Let me have a lot. I got lost waiting my permission to load model and cannot run fast enough after. I'm sorry for that, Eric. So, yeah, true. We have some time for this permission to reach your email for the Gemma model. But after the Gemma model, let me try to refresh here. Basically, so we loaded the model here. Basically, after the model, we just tested it, and no changes on the code. We just kept it as it is. And also this, we were loading the data set, no changes as well. We were formatting the data set, no changes. In this section of the fine tuning, we did a lot of changes. I tried to paste in the chat all the changes I did. You can just paste them in whatever order. Try to just make sure to paste the gradient checkpointing with the value true not after, but inside this training arguments. That's the only condition. And the other condition is setting the train data set and the validation data set, just like remapping them. Before we do this, we set the trainer. And those are the only conditions for you to paste the quotes here. So how to fix 403 forbidden error if you don't have the rights to create a model under the namespace? Um, can you help me? Can you specify the exact place? Was it in this code here, in this code block that you got this 403 error? Maybe it was something regarding this part here. Maybe you were trying to declare a model or create a model under a different user. So you gotta make sure to set your username here. And I think you can set whatever name here, because if you already have a model with this name, it's gonna override at the end if we push it to Hugging Face. So just make sure to use all the same arguments you suggest, including the additional code. Okay. Can you update me on the amount of time you have left for your training? Maybe you start after, maybe if you have like 3-4 minutes, it's still good. We can work with this. I'm just gonna delete this. Yeah, awesome. Thanks, Susan. The pool question has been closed, and yeah, let's check the results. So yeah, as I see, a lot of you guys have coded at least one type of neural network. Maybe not specifically a LLM or an NLP, maybe in computer vision. If you guys want to share this, like if you've done some computer vision work, some audio analysis, any type, would be awesome to see in the chat what type of neural network you guys have worked with. So yeah, a lot of folks are also just learning now. That's awesome. I hope that's not overwhelming for you guys. You can also access the recording after and go step by step, pausing. All right. Let's get back to the chat. If you could export the file into the TIFF, then maybe based on, yeah. I could do this, maybe not right off the bat right now. I don't think we have time for this, but I'm pretty sure all the modifications. I took some notes here, and all the modifications I did were regarding this. Like I just commented out this. I just added this function. I added this line here, and I changed those 3 values here. And also, of course, my name, my user, and the model name that I set. All right, 7 minutes left, 9 minutes left. Okay, so the name was case sensitive. Okay, yeah. Yeah, it's good that you mentioned this, because something to keep in mind for next workshops. You guys want to make sure that you copy exactly the same username that you used in the Hugging Face. And as Justin said, is case sensitive. So it's not going to allow you to create any type of model if you are not using your username that you logged in, from the account that you logged in this Hugging Face section here. All right, so I think I'm good. I think, yeah, my my training is done. So here it's cool to see because here we have a history of all the loss, all the token accuracy, the runtime, all the information is logged here. You see a history, and it's really cool to see also in weights and biases because yeah, here we have a way more complete version of the dashboard. So way easier for you guys to analyze and do some adjustments in your fine tuning. So if you get it, I mean, this is just I want to reiterate this because I think it's important to make sure you guys are able to run this all of this again using a big model. You just gotta have a big server as well, like with a big VRAM memory available, or at least memory available for you to run this training. But once you have this big server, like one in Intel Cloud in Tiber Cloud, you can take whatever other model that you want to, and you can take whatever data set that you want to use for your fine tuning. You can create different data sets. You can um, use your data as an input for the fine tuning. And with this, you're probably going to have like different arguments here. And this is going to be a process of exploration for you guys. So you're going to have to go through all of those arguments, probably not those because they are pretty sad. Like as it is, maybe the learning rate, you're going to maybe want to change. But you're probably going to want to change the batch size, the gradient accumulation, also the number of epochs for sure, and also the LoRA rank and the LoRA alpha. You're gonna make sure to try different values. So once you do this, you can see the dashboard with the final analysis and weights and biases. And this you can use to reiterate and do new trainings and adjust your arguments. And of course, this requires like a more deep knowledge on interpretation of the results here. So it's also a process of exploration for you guys. Prakashan, can you explain the role weights and biases is playing here? Sure. So weights and biases is simply the library that we are using, not the library, but the platform that we are using to access the results of the training session that we did, the training execution that we did. So at the end of the training, you have kind of a log. You have a summary of the run that you did, but it's not as good as it could be. So we use weights and biases for this nice presentation with different charts. Like you can see the evaluation, you can see the training, how the training go. The eval is the validation step, and you can see also the like measures from the system. So how was your network traffic going, and how much of the disk memory did you use, and yeah, you can see like the CPU process and so on. And you have a really neat visualization of the whole process with those full charts. Or could you understand now, or any question was about weights and biases website? I don't know if I answered your question, but if not, you can you can still specify the points.
I think Prakashan was really was interested with the website itself and its role, like right, like you're referencing Wanda
Yeah.
on a website, so that's and
Yeah.
he had a follow up here. We have to type an API from Wand AI.
Yeah. So the one B website is the weights and biases website. We have to type an API from one AI. Yeah, I think you mean one B dot AI slash API, and this is the same website from weights and biases. So this is basically setting up the connection for you, like the API connection for you to send all those data from the training. So you're taking this data, this run summary that you got, and you're sending to the weights and biases website using this API that you got from the link that you found on this output. So it's basically creating this connection for you to see in this really neat way the charts and weights and biases platform. So, Baran, can you give us a brief summary of the steps we have taken so far and why we did it? Awesome. Great question or um, request. So, yeah, let's make it smarter. Let me do this. Shrug too much. So yeah, first step is we need to set the environment. So we are using Intel Tiber, and as we are using Intel Tiber, um, Intel Cloud with Intel hardware, we need to set up the environment. So we need to provide all the environment variables for the process to be more optimized, for us to use the in the correct way the hardware that we are using. And as we are using a Gaudi, we're going to set here some of the variables for the best possible approach on Gaudi. And this is a super dense topic. So I'm just going to go on the surface and over the surface. And yeah, I'm going to say this are all the variables that the Intel engineers set for a best way to run this code with Intel Cloud Gaudi. Next thing, we're gonna initialize the XPU and monitor the GPU memory in real time. And this code here is just some functions that we are gonna use later. So we're just setting the setting up some functions for us to like uh, keep track of memory and also print the memory um, and monitor and so on. So it's just for our XPU analysis. And in the case we are using the XPU that we are using is the Max. Oh, sorry, we're not using Gaudi. We're using a Max series 11 1100. So the memory we have reserved is 30 gigabytes, and it's pretty close to what is allocated at the moment. So yeah, probably because we have two chips here. So the next step is configuring the LoRA settings. So we are going to configure all the settings and attributes for our um, fine-tuning process. So as we're using LoRA, which is the low ranking adaptation method for fine-tuning, we have a bunch of methods, and we're going to focus on this LoRA method, which is the reducing, kind of compressing compressing the model to make it easier for us to train again and fine tune and so on. We're using LoRA, so we have to define the rank and the alpha arguments. And for the rank, we set 8, and for the alpha, we set 32 again. The rank, the lower, the more you compress the model. The higher, the less you can kind of compress this model. And alpha, the higher, the more influence you have on the new trainings with the new weights that you are setting. So next step is loading the Gemma model. We are retrieving this model. We are fetching the model from Hugging Face, and for this we need to log into Hugging Face. Then you provide this token for you to access Hugging Face, and then we are just retrieving the model to save in our server, to save in our disk. And we, as I said, we fetch it in 2 chunks of data, as it is a small model. Some of them they send in 4 chunks and so on. And then we test the model. We see how good it is. We ask some questions, and then we got the answers. Pretty bad, but that's how the Gemma 2B operates. And then we are retrieving the data set. We got the Databricks.e15k data set. We did some filtering of the categories in this data set we were going to use. So we selected some types of the questions it was from our interest to use. And then after this, we just define the data set with doing some split. And here we define the proportion of the test. So 20% for the test, 80% for the training. So after this, we run the fine tuning itself. That I think you guys are probably reaching the end. And then once we run this with the modifications that we did, we get a new model, and the new model is saved. Not yet saved in your Hugging Face, but it's saved in this. Let me show. So it's saved here inside this folder. You're gonna see there is a new folder here with inside your usernames folder. There's gonna be a folder with the name of the model that you created, and if you go inside, you're gonna have all the definition for the model that you created, or not created, but you fine-tuned it. You're gonna have all the checkpoints, all the tokenizers, and so on. So yeah, this is a pretty cool space if you want to explore. So awesome. Once we have the model, what we want to do is the final step. We want to save this model, and we're going to use Hugging Face again to save this model. And let me just so we're going to save this model with this section of code. So let me check if we need to do some modifications to the model. Yeah, that's correct. So here you got to define the name of the model that you're creating. So you can name whatever. Let me use the same name I used before. So our tuned model is going to be named MyNewAgile. Let me actually do this MyNewAgile after the Gemma 2B.UQA. Because here we're defining, like, we use the Gemma model and then we fine tune it using the Dolly QA dataset. And then you place your name here, the model's name, and yeah. Basically, it's going to create the model ready. It's going to make the model ready to be pushed to Hugging Face. So we're going to go ahead and run. It's supposed to be quick. Yeah. So now what we're gonna do is we're gonna test the model again. We're gonna use the same questions that we did in the past, and I I actually want to ask what you guys expect to see here as the answers. Like, how different do you guys expect the answers to be in this scenario? Like, as after we did some fine tuning, you guys think it's gonna be like super different, totally new answers, or pretty much the same answers? Let me know in the chat, and I'm gonna run this. So it's answering, and yeah, as you see, it's pretty much the same answers. And why is the reason here? So the thing is, we reduced so much the fine tuning process, because a good fine tuning would take like at least some hours, depending on the application that you want to do. But a good fine tuning would require more than like a couple of minutes. And we only did one epoch. We had a low alpha value, so it was a low influence in the new weights. So we're not playing too much of a fine tuning in this model. We just went through the steps for the fine tuning, but we're not essentially modifying the weights in this model. We did a little modifications, of course, but not that big of a deal to like change a lot of the answers here. So yeah, once we have this final model, we can go ahead and push to the Hugging Face. So I think I have some lagging. Yeah, okay. So we can push this model to Hugging Face, and it's gonna go ahead and like show you the link for your new model. You can copy it. Actually, this is a better link because it's not quick to commit. Let's see if you can just copy this. So I'm gonna paste this link here, and yeah, as you see, this new model here that we fine-tuned it is already in my profile, and you can leave a like here if you want. You can see all the settings that you use for the fine-tuning of this model. So we used TRL as the method for like retrieving it and running the weights assessments. We used a version of the model. This model is a version of the Google Gemma 2B. And yeah, you can also change this model card. You can like place more information. You can write tags here or here for like you use the max series. My bad. You use the max series as the GPU. And with this, we go ahead and commit. And there's a pretty cool. I see we have 5 minutes left for the workshop, so I just have one last thing to share with you guys. It's a pretty cool stuff that you guys can participate. So Intel created a leaderboard for the models for you to use your LLMs to compete in the leaderboard. So you can just take whatever big LLMs you find, big models you find online or on Hugging Face, and you can just run this process all over again. You can fine tune, you can provide with a new data set for the model, and you can submit your model here for a chance to like compete in the leaderboard, and place your model and the charts here. So the process is pretty simple. You just open the submit. I'm gonna place this link in the chat as well. And the process is really simple. You just go to the submit tab, and you're gonna write your model's name. So mine would be this whole model here, whole name. So it's my username plus the tag for the model. Then you just put like fine tune. You select the hardware that you use for the training. So we use the Max series, and you check that you agree for the model to be evaluated. Then you select the precision, the types of the data that you use for the fine tuning. So let's check what we used. We probably used F. Yeah, we probably use F, FP16, and then the weight types. So we use the LoRA, so it's an adapter. It lowers the rank. So you select adapter, and you use the what is the cloud that you use or the server that you use to train. So we use Intel Developer Cloud. Then you select some affiliation with Intel, and then you just submit your evaluation, and that's pretty much it. Revision name. So
Yeah, Yuri. Will you be able to hang around and even though after the workshop on here and answer any of the questions? We have a long break after this, so it's like a 30-minute break. But I think there's a few questions. I think Beneath Agarwal had one. If you need to use a Gen AI model to identify and catalog something from images, is that a candidate for fine-tuning more than RAG?
Nice.
I could.
Yes. If you need to use Gen AI model to identify and catalog something from images.
My thought was it was fine tuning more than RAG because RAG is really trying to find specific information about a like a person thing, whatever, right? It's an additional prompt versus fine tuning. If you're trying to extract something from an image, then
totally. I think this would first. I don't know if I totally understood your question, but like something to identify a model to catalog and identify stuff from an image. I don't know if it would fall into the class of like computer vision models more appropriate for this. If you want like a multi-model neural network that you could like input an image and then it also responds with a like output like an NLP with some text, maybe the fine tuning would be more fitted for this application as Tree said, because RAG would be like for just providing you a database for knowledge, like more text based. And I think like this multi-model, we would need to provide more images adapted like with the labeling, with the stuff that you want to classify or identify. So let me know if it answers your question. Yeah, awesome. for submission is base model, Google GMS to be, yeah, correct. If you want to change the model that you're gonna use for the fine tuning, you're gonna need to adjust this in the code. So it's as easy as doing a Control F and finding all the Gemma 2B applications, and then you just replace with the new model. So if you want to use, like, let's say DeepSeek R1, I don't know if you're gonna have enough server for this. Probably with a Gaudi 2, you're gonna have plenty of memory, but you can try with whatever model you want, and then you just adapt the model ID and the code.
And so Yuri, we're at time. We're at 10 o'clock, or I guess noon for the calendar. So we'll have to wrap it up. So I'm going to go through the. If you want, for those of you, Yuri can still hang on here and stay in the session, but I just need to close it out so that people know it's over. And Yuri, if you want, or you can also hang out in there's a community chat as well. If you go in after you leave the session, if you go to the top and you go under community, there is what's the word here? If you go into community, it says explore community, and then from there, there's a chat, a discussion, and we're discussing LLMs there. So it's a good place to kind of just talk about LLMs and what kind of stuff you're using and so forth. So I'll leave that with that. So with that said, I'm gonna close the session. So I want to thank you, Yuri, for that informative workshop. And if you're interested in more AI, Yuri already talked about the Hugging Face repository on the link. But feel free to check out the Hugging Face. I'm going to put that link too. We have a bunch of LLMs there that you can check out that are tuned for the basically on the Intel platform. So check them out. Once again, thank you, Yuri. We have a 30-minute break, and then we'll be back. And I will introduce Miriam Eric from Titan ML. Her talk is going to be is navigating LLM development tips, tricks, and techniques. So feel free, take this break to check out all the cards we have, the resources we have, get involved on the chat, and we'll see you when we get back from the long break. And if you have any questions, please use the community chat I was talking about, and I'll try to answer anything you have. All right, Yuri, it was a pleasure. Thank you so much.
As always, thank you guys. Right. Thank you all for the attendance. Bye.